Yeah. Well, it's interesting. I wanted to put this presentation together, because I am a novice at this. I mean, I've only have done 3 mosaics, and each time I do one, I learn a little bit more. Um, I'm probably the least qualified person to give this talk, but it's a learning experience for me, and just putting this talk together gives a chance to organize the things that I don't know. and so this was kind of a good exercise for me, and in fact, I even have some questions myself at the very end that I can ask somebody who is. I think Jeff and most of you have done mosaics, right? All of you.
I personally have never done them.
Me neither.
Well,
Nope.
I know Gabe has.
Yeah, I've done them, but they tend to disagree with me. It's more
Okay.
difficult than usual for me to do mosaics. So
Yeah. How about you, Thomas?
No, except moon.
All right. Okay.
So you are the most
Oh my
experienced.
gosh, we're in trouble tonight. All right. Well, let me go through this. Like I said, this was a way to collect my thoughts and to kind of at least organize an approach to mosaics. So as an overview, I'm going to talk a little bit about planning software, which I tried. My first mosaic, I tried just eyeballing things and just anticipating, how much overlap, and I proved to myself you truly do need some kind of planning software that creates the panes and the matrix for you. That's clearly essential to get any kind of good results. Then there is preparation of the panes themselves before you actually start assembling them into the mosaic, and I'll go over what I do anyway that has yielded fairly good results for me. The approach that I take, which I think is pretty common, is to build a mosaic framework first, to kind of allocate the space for all of the panes. And then once we create that framework, then we'll register the panes, within this framework. And then finally, we will create the final mosaic. And please jump in, anybody who has any questions, or if I say something really stupid, I'm never offended by that. And so feel free to make this as interactive as you'd like. As most of you know, I'm kind of stuck not stuck. I work in the world of SkyX, and in fact, just recently discovered about 2 or 3 months ago that SkyX actually had some planning software. It's not very sophisticated, but it basically allows me to control the amount of overlap and the number of panes, and then position those panes, and it actually remembers this entire structure, so that when I come back another night, all I have to do is just, unless I clear this mosaic, it remembers where it was at, and so I can do new panes each night. So a pane is what I'm referring to is just this one portion of the object. But what's really important is what I call the overlap of the panes, because the way the processes that we're going to use tonight help us or assemble this mosaic is by doing plate solves of these overlap regions. And so so one of the things that I learned the hard way is if there isn't a minimum of a good 15 to 20% overlap, you do have chances of not being able to do a plate solve, and then that pane is just gone. Okay, and so good planning software, and I'm probably the only one that uses SkyX for mosaics. I know, Jeff, you have what is it?
Yeah, Sequence Generator Pro has
Yeah, Sequence Generator Pro, right?
Yeah, they call it a framing and mosaic wizard.
Yeah, okay. And Gabe, what do you use?
I'm using Voyager, and it allows you to do something similar where you can arrange the
Yeah,
panels in your mosaic
yeah.
and the overlap and the stitching and things.
And does it remember it from session to session, so you can, once you create your
Yeah.
your frames?
Yeah, the frames are stored in a database, and then you can retrieve them at any point.
Yeah.
So you can retrieve them years later if needed.
Right. Okay. So and so SkyX, of course, there's no real automation. I can't actually go from frame to frame in when I build a sequence or a series. But that's fine. I'm more of a hands-on astronomer anyway, and not a real big fan of automation. Gives me something to do. But planning software is essential, especially in making sure that you have this sufficient overlap, but between all of the panes. Okay. Just some basic guidelines here. And again, this is, there's going to be some choice to the individual here. But there are some certain things that, if you're going to be using the processes that I'm going to show you out of PixInsight, all the images need to be linear. You can't have any stretched images. And of course, I have never worked with one-shot color either, and so what you're actually doing is, so for the narrow band work that I'm doing, I actually build 3 mosaics, and out of each of the master filters, and then I take those 3 master mosaics and then combine them into a final RGB. I tried doing it the other way. I tried, making, the RGBs, individual RGBs first, and it just didn't turn out very well. So I'm not sure, because I don't have any experience with one-shot color, but building the mosaics from each of the filter masters, and then building the RGB from the 3 mosaics turns out to be the best approach, at least from my experience. It's really critical that you pay attention to any edge artifacts, because you are trying to merge and overlap these panes, and so any integration edge artifacts have to be gone. So you want to make sure that you dynamically crop all of your images, and make sure that there are no edge artifacts.
Dennis?
Yes, yeah.
So you're kind of trimming the edges here, which I understand. As a practical matter, does that ever cause you any trouble? Where you have to trim it halfway to the center of the frame or something weird like that? Or
Oh gosh, yeah. Well, okay, so that's gonna play into if you've got that much misalignment in your integration. Usually, most of us have maybe a handful of pixels at most. But if you've got really gross artifacts, then you're going to have to increase that overlap. You know, because if you start cutting into your images, then you're not going to have sufficient overlap to do the plate solves.
Okay, so as it's not really a big problem, but it's something you have to watch.
Yeah, it's something you have to watch. I usually have just 3 or 4 pixels at most, around the edges of my integrations,
Mhm.
and but even just 1 or 2 pixels is enough to cause artifacts in the final mosaic.
All right,
So
thank you.
you definitely want nice clean edges. I do a little cleanup. I do kind of, and this is part of my normal routine is I do some background extraction. I do a dynamic background extraction on each of the panes because you want to try and get these panes as uniform as possible, so that the final product is very uniform throughout all of the panes. So I do a dynamic background extraction on each pane. I do a multi-scalar linear transform to, eliminate some of that, early noise, again on each pane. And then the thing that really makes for a really quality looking mosaic is to actually, balance the intensity of each plane relative to some reference pane. I'm going to actually talk more about that on the next slide. There's a really great script that I can share with folks. It's got a great name. It's DNA Linear Fit, and it was written and designed just for this purpose of when you've got 2 panes that are overlapping and each pane has slightly different intensities. This script really helps normalize the intensities across all the planes. And if you're interested, I actually couldn't find the original source where I downloaded the script from. I actually went back to that site and it no longer exists. Maybe he moved it or whatever, but I have the script and the author, so I can easily download it to anybody. So I think we're all used to, in balancing the intensity, between images. We've used linear fit. Linear fit will not work across different portions of the object in the panes. Linear fit is designed to have 2 objects or 2 panes that have very similar objects and content. If you try using linear fit, you will actually completely destroy one of the other panes. But this DNA linear fit is really a script that's designed to match brightness levels between areas of the 2 images that overlap. And this is a really cool script. And I'll actually demonstrate it in the demo portion of the program here. So the last step in preparing the panes is to try and get a good match in the brightness between the panes. Okay, so now we've got 4 very well cropped and noise reduced and good background rejection or extraction and of course intensity matched. So the first thing this process or this series of steps that I use is I actually build a mosaic framework, and all I'm doing there is allocating space and putting a framework together that I'm actually going to register the panes into at future steps. And so to do this, you use the star alignment process, but there's a couple unique settings here. The registration mode here is thin plate splines. Please don't ask me to explain any of this. These are just the settings that I've gotten off of the internet and from other demos. And of course, the working mode is to do a union or a mosaic. And again, I'd be happy to send every, I have a set of icons that I have, made all these changes in these processes that then it becomes a no-brainer, for me. So the first thing we're going to do is take two of our panes. I'm going to use our first pane, pane number 1 as a reference. And then I'm actually going to drag this process and drop it into pane 2. And we're going to actually start building the framework. And you'll see this, you'll actually see the mosaic start coming together. The seams between the panes won't be very, very good. But really what we're doing at this point is just allocating this, the space and the structure that the mosaic is going to go into. So when I do that, I end up with a new reference, and I use that image, that combined pane 1 and pane 2 as the new reference, and then I drop that process into pane 3, and then I repeat this for pane 4, and so I will actually end up with this mosaic reference frame that I will actually use to register the individual panes against. It actually becomes a lot easier when you're seeing a live demo, and but I thought I'd just outline the the steps and the settings in the slides. And then so what we're going to do then is we're going to take that master reference that we created, and we're going to use that as our reference image, and we're going to still use star alignment, but we're going to go into two different modes. We're going to go into a projective transformation, whatever that means, and then the working mode is we're going to register and match the images to this reference frame. And then we just simply drop our 4 original panes in here and let it rip. And it's going to actually register each of these panes individually with reference to the master frame. Okay. And then finally, the last step, and that's what this whole process is all about, is using this what's called a gradient merge mosaic. And so what we're going to do is just open up this process, drop in the 4 registered frames, and there's again there's a lot of trial and error. I've tried a whole bunch of different settings here. The general rule is if you're making a mosaic out of something that has a lot of nebulosity, you'll want to use the overlay combination. But if you're doing big star fields and most of your panes are stars, then the average mode seems to work better for this combination. Shrink radius and feathering, basically all is fine adjustments of how it deals with the interfaces between the panes. These are the numbers that I've been real happy with, and again, I just don't change them. Okay, so there is a great I've looked at maybe a half a dozen different YouTube videos, for using this kind of set of processes. This one is I think is the best and what I've modeled most of my talk over. And so I've included this in the link. And again, if anybody wants the PowerPoint, this is a pretty small PowerPoint. Just email me, and I'd be happy to send you this PowerPoint, and then that'll give you this link, automatically. Okay, so so at this point, I'm going to just do a live demo, but is there any general questions about just the steps in the process that I'm going to go through? All right, so let me go and I will minimize this. And all right. Okay, so these are the icons that I use. This is just the screen transfer function, of course, and dynamic cropping, so that I make sure that my background extracted and noise reduced frames, when I bring them in here, I will set up a crop region and then create a icon for that crop, and I'll crop all my images, the same amount. So let's just take a look at the objects here. So you see here, these are all dynamic background extraction, MSL, multi-scalar linear transforms, and they've already been dynamically cropped. So here are my 4 panes. And so the first process I'm going to do is I'm going to pick pane 1 here as my reference, and I'm just for an example, just so we can see them side by side. There's not a lot of variation here, but I'm going to scale everything to my pane number 1 here. And so to do that, I just run this script 3 times. It's called DNA linear fit. And basically, so I'm going to use frame number 1 as my reference. And then right now I've got frame number 4 up here, which is appearing in here. And so I'm just going to execute that. And I'm just going to, and so a little bit of a change. Normally I don't see a lot of difference between the two, but it sure seems to make a difference in the final mosaic. So I don't need this guy anymore. I'm going to just tuck him down here. I actually don't need number 1 anymore. I'll use it as a reference. So now I'm just going to go through the individual panes here, and so I'll just go back to my script, execute script. Still going to select number 1. This time I'm going to do number 3. Oops, that's number 2. All right, and so I don't need that anymore, so I only tuck that away. So let's put this over here. And then finally, I need to do this last one. One is the reference. And this is number 2. Ooh, that's a dramatic change. Redo that. Okay, so I can tuck these away. I'm going to leave these all as active views. So these have all been now scaled, or fit reference to pane number 1. Okay, so let's build our frame. And so what I'm going to do, our framework. So what I'm going to do is I'm going to select frame number 1. There's frame number 1 as a reference. I'm going to open up frame number 2. There's 2. And I'm going to drag this over here, and I'm going to start building my framework. Okay, so I don't need this guy anymore. So let's take a look. And so now we're starting to build, and you can see these obvious transitions, and I want you to make a mental note of those, because those are all going to magically disappear in the final product. So what I'm going to do is, because this is a god-awful name, I'm going to just change this to A1, A2 as my new reference.
Hey, Dennis.
Yeah.
So in this example, you can see, even though you used your planning tool,
Mm-hmm.
and you had every intention of having your panels be a little bit more consistent, this is how they ended up.
Yeah, and that's exactly the question that I wanted to discuss with you guys after the end, because I'm seeing a disagreement
Yeah.
in my planning tool and even this preliminary framework.
Well, the only thing I can think of is you planned, to have nice 15% overlap, but when you actually went and did your, closed loop slew to center on that panel, you weren't actually probably pointing where the planning tool was.
Yeah, well, okay, so it's interesting. So the way I did that is I did a closed loop slew to the there is a center for the panes, and so I slew to that center first,
Or so you thought.
or so I thought, and then just clicked on the pane, and because of the pane actually comes up as an object.
Yeah.
And I can slew to A1, and then slew to A2, slew to A3. But I haven't figured this out, that there is, I'm not sure what I'm doing wrong with the planning tool.
Yeah.
That caused this discrepancy. Obviously, I'm not where I think I was at. But my pointing accuracy with my T model is pretty close.
Pretty good, yeah.
It's within it. This is certainly more than 13 pixels.
It just drives the point home that don't cut yourself short on the overlap.
Yeah, and clearly, more panes are better to make sure that you don't end up with this kind of effect.
Yep.
All right, so did I read
I have a quick question.
Yeah.
Did you check that the angle of your rotation of the camera is where you thought it would be? Because if you're maybe angled 15 degrees or so, then that might cause some misalignment like this.
Interesting. So what would, in such a small region of space, my cameras, I don't have a rotator or anything like that. So I wouldn't expect, so my camera angle is fixed.
Okay.
And I have no control over, I don't have a rotator.
Yeah.
That would certainly do it, but I'm pretty tied down.
One thing to check is after all the mosaic is done, before like rotating it and cropping it, is to do like a plate solve and check the angle there. If you're more than, I mean, if you're far away from 0 or 90 or whatever you have your angle set at, then that might cause this misalignment.
No, okay. Interesting. Yeah, that's exactly one of the discussions I wanted to have tonight, because this really has baffled me into figuring out a solution for this.
So Gabe, are you talking about the frame in the Sky 10?
I'm sorry?
I'm asking
No,
Gabe if you're talking about the rotation between your camera position and the frame in the Sky 10.
Right. I think it's, yeah, that's effectively what the question is. If you have, if your camera is rotated and it's not reflected in the sky, in whatever framing software you're using, you're going to have this misalignment.
Oh,
really,
I see what you're saying. Yeah. Oh, that's
really, what's being done is the center of the right panel and the center of the left panel, you draw a line connecting the two. And if you rotate the panels along that line, then they will form a completely solid rectangle. And that's the misalignment that I think that is going on. I don't know. I don't think it's a pointing misalignment. Like you said, you're using T-point, so it's going to be pretty accurate. It could be an angular.
You know, I should check if there's a rotation setting within that tool, that mosaic tool. And it may not know about where the camera actually is at.
Mm-hmm.
Oh, that's a good point. Okay. All right. So I don't need this guy anymore. So let me put him over here. So now I'm going to use this first reference here. So these two panes combined. And I'm now going to open up number 3. And I'm going to create yet another reference. Boy, I bet you that's it, Gabe. I bet you that planning software doesn't know what my camera is rotated at. All right, so let's take a look. All right, and so you see, yeah, see how more stuff comes up. And in fact, that's strange. I actually haven't seen that before. Well, it'll be interesting to see how this one comes out.
Yeah, let's just hope frame 4 is going to take care of that little guy.
Yeah, I actually haven't seen that before. So let's A1, A2, A3. That down here. Don't need that guy anymore. So now I'm going to do my last one. Going to be there. And I'll open up number 4. 4 over here. Yeah, yep, okay, so we got rid of that little strip. So now we're going to use, this is our completed frame. And so let me change this identifier. A1, A2, A3, A4. So I don't need that anymore.
Yeah, you can see the offset is symmetrical. It makes that pinwheel look.
Yeah.
So that's almost most likely what it is.
Yep. Oh boy. See, I knew if we put enough big brains together here. All right. So now I have this framework. Now I'm going to register each individual pane relative to that frame reference. So we're just going to do another star alignment thing, but now the registration mode is this projective transformation, and the working mode is to register and to match the images. And so I'm going to now use that master frame, which is all 4 of them together. And I'm going to add these views. Okay. And now it's going to register. So I'm going to end up with actually 4 new panes that have been registered to the framework. Now the last step requires, it doesn't allow me to work with views. And so the last step here before I actually before we do our drum roll and have our final mosaic, I actually have to save each of these individual panes and registered panes. So if you look at this one, so basically it is just this piece, but it's registered relative to the master. And I do have to save this. Let me save it. And so I can actually get rid of that now. And here's another piece. And do a save as. Okay, get rid of that. Here's our upper piece. Save as. And then finally, here's our last piece. Do a save as, and you see these panes then get this underscore registered tag. All right, so now the last step is to actually use this gradient merge mosaic. And this allows me to then make that final mosaic. Okay, so put those registered ones in there. So I'm going to use the overlay mode and, you know, my favorite settings here. And so we're going to create this. So, and what we're going to look for is really all those seams and hopefully we will have a pristine mosaic at this point.
So this gradient merge mosaic is really just a special case of integration, right? Image integration. It's probably got the fancy features of how they feather the.
Yeah. Right? But well, it's actually not an integration per se, right? I mean, it's actually building. And so I'm going to make this bigger here. All right, so that's our final mosaic. So you ready?
Drum roll.
There it is.
Wow.
And you know the one thing that you know if you scroll around here, it really does an incredible job with all of those seams that we saw. I have yet to see anything that resembles any kind of interface. And I, you know, actually on my next mosaic, whatever that's going to be, I may just redo this one just to prove the point and check that camera rotation. But this does a great job, but it's a pain in the butt. I mean, it is a lot of work, and And like I said, I've started putting more money aside for a new camera.
You
There's
know
always a new camera.
what you just showed, I didn't think was terribly. It wasn't the work. The work was you pre-processing these as 4 individual frames before
Oh
you.
yeah, oh yeah, building them
That's where the
was,
work is.
yeah, yeah, and acquiring the data, right? All the,
Right.
yeah, all of those panes is, basically, and this was, I just wanted to do this quickly. These are only 5 subs. I mean, I would normally be doing 15 or more subs
Of what exposure length?
15 minutes.
Okay.
And so I wouldn't accept this. I wanted to quickly get some data in the can. And because the only other mosaics I had were just 2 panes. And so I wanted to at least show what a 4-pane mosaic looked like.
Yeah.
And so I hurried up. It's taken me weeks to just get 5 subs.
Well, this is December.
Yeah. So this is really not a lot of data. And so literally, yeah, it's an hour and 15 minutes for each pane.
Dennis,
Yeah.
is there, I think I understood the process you were going through with merging photos into the mosaic and then getting everything adjusted. Is there some sort of accepted grading system that tells you the quality of the integration you have? Like in the process of doing all these things, did 5 magnitude stars suddenly start looking like 7 magnitude stars, or some weird interruption and like that? Or is it just kind of looks good to me?
Yeah, I've never seen any, I mean, you're like Jeff says, you're as good as your individual panes, and the steps of actually and how you stitch those panes together is really all embedded in the processes, and those PixInsight processes. And so you're really putting all your efforts into getting the the best looking and the best matching panes intensity wise. But I've never seen any real problems with the stars or.
Well, it was, suppose you were holding a contest and you have 5 processing packages and the lenses were the same and the imager is the same and all of that. How would a judge go through and say this one is the best and this one is the worst? With the idea being you could then learn from it and saying, well, the thing that I did that made it the worst was this step, and I'll modify it to be something else.
Are you referring to the overall mosaic, or?
Well, that's probably the easiest thing to look at.
Sure.
Is look at it as a photograph or as a work of art or as something, and just say which one looks the most like what we believe the object actually would look like if we were standing next to it. Well, a little farther away than that. But.
I'm not sure I follow, because I mean,
well, let's say you're evaluating, you have a half dozen software packages that are equivalent to what you've shown us tonight. And you want to say you're writing an article for a website about, which one is the best one to buy. When I look at those, they talk about how many pixels can you handle it, how fast does it go, how much control do you have, and on with all of those things. But there's never, I just have that mindset of school days with, is it an A, B, C, or D, or F? And
I mean, I know what you're asking, Scott. I think honestly the only metric that you weigh one is really the eye of the beholder, or right?
Well,
Right.
but that's a legitimate answer. You just have to own up to it. I like this because I like it.
Yeah. Or I can see the knit line still in using this software, and this one I can't, right? It might be
right.
that.
Yeah, that's a good tangible thing that everyone can point to it and they can agree it's there and they can agree it doesn't really exist. It's an artifact.
I just don't know if there's any other like quantifiable way. I'm sure somebody smarter than us could find a way, but
That's a long list.
Well, I mean, clearly, if you look at, I mean, it is really obvious, where these interface lines are at,
Mhm.
right?
Oh yeah, the one you're moving the cursor
Yeah,
over.
yeah,
There it
yeah.
is. Yeah.
I
One
mean,
thing
that's,
that
I mean, that's the, and it's interesting, before this, this gradient merge tool, this is, and just historically looking at older YouTube videos, this was something that people were trying to deal with, without that tool.
So it was recognized it was there, that it was an artifact of the software, the algorithm, the whatever. And if they are trying to improve it to get rid of it, it must be seen as a bad thing to have. So,
Oh, sure. Yeah.
yeah. So again, is there some way you can judge these apples to apples, the outcomes of the packages? What sort of things do you look for?
Yeah, other than, other than the obvious here, I mean, it's really clear in looking at these at these two images.
Yeah.
I think there are three things that you can look for. One is the seam that is obvious in that first one, that isn't really even using the gradient merge mosaic, but it is still a mosaic, and it shows seams. Some software does that, and I was, before they came out with gradient merge mosaic, I tried to do mosaics using the method by hand, and it was a nightmare to
Right.
try and get the balances right and everything. The other two things are that on the stitching that I've encountered, on the stitching between the frames, sometimes the star registration gets kind of wonky, and you get double stars, where in one frame, if you have enough distortion in your lens or your system, your telescope system, in one frame the distortion won't be picked up, but in the other the distortion will, and that'll create sort of a double star effect. That's something that I saw a lot in my my mosaic of the question mark nebula. And then another thing that you can see is if you do the gradient merge mosaic on average mode, what you're doing is you're averaging between two panels, and you're averaging the noise between those two panels on the overlap, and that averaging will decrease the noise. So the noise profile on the overlap will be a lot, it'll be a lot less noisy than the frames themselves where there is no overlap. So those are some objective things that you can look for in an image. Now, if after merging and doing the merge mosaic and all that stuff, you can apply noise reduction and stuff like that to try and reduce that. But raw frames out of the gate, when I merge them, I do notice that the noise profile is very different on the overlap, and then you treat that with noise reduction.
Well,
Right.
I
Well,
know.
Gabe, I'm
that-
actually, sorry, that's great. So I'm working on the question mark nebula right now as a mosaic, right? The biggest problem I see is, and this has happened in the past, is where there is high signal, usually there's no issues. Everything works great, like what Dennis is showing here. But if you look at the background where there's a very low signal, that's where you end up seeing either you acquired on different days, the moonlight was different, the background gradients are different, or the noise texture is different. And whatever you post process, it's still like, hard to kind of, you can't stretch too much, let's put it that way, right? Then it'll show up.
Right.
Yeah, that's one of the things with mosaics that makes it a lot more challenging, is making sure that you do have a very good treatment of your individual frames, so that there are no gradients, there's no vignetting, there's no cutoffs at the edges. And if you don't mind, I can share an image I have of the question mark nebula that I did with this process. I can share a screen real quick just to show. Where is it? All right. So this is one of my HA frames, and it's the stitching is in the middle here, and if I zoom in and get these guys out of the way, it may not be evident on the call, but the noise is a little bit different in the stitching, but also I have some other issues with something like this. This happens a lot with the
Oh.
gradient merge mosaic. When you have stars right at the boundary, it'll create these little black hole effects, and you either have to go in and adjust the, is it the feather radius or something like that?
Right. Yeah,
Or-
I've seen that. Yeah, for sure.
Or apply a mask, or select the
Or
box
you
that
just
says
cut it off.
create masks,
Yeah.
and then make a clone stamp and make a little hole there so that it never sees
Yeah.
the star when it's doing the merge.
And that's
another
actually
approach.
easier, I've seen, because it doesn't really care, right? You can make it bigger, smaller, as long as you just blacken that whole star area.
Yeah,
It works out.
So I think, as Gira said, this is a low signal area, and above here there's more noise, and down here where there's an overlap, there's a bit less noise. I can see it a bit more clearly than the example I had earlier. But up here there's more noise, and down here there's less noise. So that's one thing that you can see objectively, that this was a mosaic by looking at that noise pattern.